Hi, hello, vanakkam, namaste, and welcome to Learning Legacy. Today's topic is Wein's law on Rayleigh Jeans formula that is given by both the scientists. This is Siddharth here with you on your legacy towards learning. So, if we see towards the Wein's law, he mainly stated that the lambda max, that is the maximum wavelength into the temperature, always be a constant for any light source that you take. The last thing which you see, if you remember, the E lambda emissivity is equal to T to the power 5 into small f, that is the function of lambda T. So here if you noticed, the capital F of lambda T is equal to lambda T power 5 into small f of lambda T. So if we substitute f of lambda T, small f of lambda T will be equal to capital F of lambda T by lambda T power 5. So finally we will get lambda power minus 5 into capital F, a function of lambda T. So we can also come to a conclusion that e power lambda emissivity by t power 5 is also same for all black bodies. Notice all black bodies, not all sources of light. Lambda max into t is equal to constant that he mentioned above is also a constant which is named as b, which is equal to 2.895 into 10 to the power minus 3 meter Kelvin. So this is an important thing to remember. No tricks, just remember this one. E lambda d lambda is equal to C1 by lambda power 5 e power minus C2 by lambda t into d lambda. This is the formula given by Weins to fulfill the graphical methods which we got through practical drawings when we studied about black body radiations. So what can be the observations and the problems, the advantages and the problems that we got through Wein's formula? So Wein was pretty much successful in explaining the lower ranges of wavelength that his formula was able to exactly match in that graph. But a noticeable thing was also observed when he performed these experiments. When temperature of a body increase, the maximum energy is displaced towards the shorter wavelength. Image will be displayed as it is not in the notes. So Wein's formula only satisfies for the lower ranges of lambda and then deviates. And then it goes straight and deviates. It does not bend and just fulfill the whole curve. So his competitor Rayleigh Jeans came up with a formula saying that his formula was the brightest. Let's see if he succeeded or not. He told that E lambda d lambda is equal to 8 pi kt by lambda power 4 d lambda. So there we saw a relation with a lambda power 5 in the denominators. Here we see a relation with respect to lambda power 4 in the denominators. So there is a relation you can remember easily by connecting them. Please connect them to remember. This formula you may wonder how it was found out. So it was found out using the equipartition of energy. Rayleigh Jeans formula worked very well for the higher ranges of lambda, that is higher ranges of the wavelength, that is the more the values of wavelength you got after the curve bending. The same thing was fulfilled by the Rayleigh Jeans formula. So we have Wein's formula for the lower wavelengths and the Rayleigh Jeans formula for the higher ranges of the wavelengths, or what we call the higher ranges of wavelength is ultraviolet catastrophe. So he again took the same thing that was said by Weins. Lambda max into T is equal to B. He just added he multiplied K to the T and divided C. So obviously we know if we multiply K and divide by C, that same will be applicable towards the constant which we get through lambda T. It becomes Bk by C, which we call it as X1. We will later on see the values of X1 to be 0.2014 into H. So we will see it later. Now we will see what this formula means to us. K. What is K, you may wonder? It is the Boltzmann's constant which we study. K into T is the thermal energy, and the wavelength by the speed of light that we get by lambda max by C. It is the dimensions of actions as we call in physics, or the angular momentum as we know all that we studied in our school days. I hope these topics are clear to you. We will continue Planck's radiation law and the Planck's formula that he derived to fulfill the graph, and let's see if we succeeded. If you like the video, please share, subscribe, and like it. I hope this helped through your legacy of learning for your life. Thank you.